Today we are going to be looking at past paper questions for straight line coordinate geometry. So when we've got those classical things that we're looking at in terms of our formulas and our little toolbox of approaches, how do we see them and use them when it comes to questions? So our first one is one of those beautiful diagrams. Diagram shows a parallelogram, ABCD, in which the equation of AB is y equals 3x. The equation of AD is 4y equals x plus 11. The diagonals AC and BD meet at the point E, 6.5, 8.5. And they want us to find by calculation the coordinates of A, B, C, and D. And this is a 9-mark question. So we've got quite a lot to step through and keep track of. So this is the kind of question where our subheadings are absolutely crucial. It's the best way to keep track of what am I doing and working through. So a good hint is to solve first for the one that comes first, and the first one they ask us for A. And if we look at A, we can see we've actually got two very useful lines here. We've got an intersection of two lines, so that will give us our coordinates for A. So we shall start out the coords of A. We've got y equals 3x, and we've got 4y equals x plus 11. Well, straightforward, you can just substitute in for there. So 4 by 3x equals x plus 11. So 12x equals x plus 11. And therefore, we're going to have 11x equals 11. So x equals 1. So we've already got x. Straightforward then, y equals 3 times 1, which is 3. So we make a note. A equals 1, 3. And what can be really helpful here is we actually go back to the diagram and add in the coordinates, because it may be useful for the next piece that you're going to do. So now we know that A is 1, 3. Let's have a look at again here and say, right, B, D, and C. So B, we don't have a second piece of information yet. D, also we're lacking a second piece of information. But C, we have a beautiful little pattern here. Never forget the value of your vector step. See, from A to E is exactly the same as from E to C. Now we've got E and we've got A, which means we can get that vector step, and then we can apply it to E in order to get to C. So we're going to go from A, now we're going to get C. Then we'll have a whole lot more information to work with for B and D. So our next one, coords of C. We know that A to E, the vector step, is equal to E to C. So what is AE? From 1 to 6.5 is a 5.5. From 3 to 8.5 is also a 5.5. So AE equals 5.5, 5.5. Decimal form is just easier when it's in a vector. So now for the coordinates of C, E to C is exactly the same thing. So if we start from E and add on our vectors, then we're sorted. So E was 6.5, 8.5. So 6.5 plus the vector, 8.5 plus the vector. So C equals 6.5 plus 5.5 gives us 12. 8.5 plus 5.5 gives us 14. Now we've got clear coordinates for C. Back to the question. C is 12 and 14. Now, given this repetition, we've got another little lovely vector relationship between B and D. So the question now is, which one are we going to do first, either B or D? If we look at B, you see, we can't step across to it because we don't have D. But we have one line leading into it. So if we can get another line leading into it, then we're on the right track. So how could we get the line going into it? Well, this is a parallelogram. We've got a point, and if it's a parallelogram, we have something to do with gradient, because these two sides are parallel, and we have this one. This is now y equals 1/4 x plus 11/4. So we know the gradient of that, therefore we know the gradient of that, and when we've got a gradient and a point, then we can use our y minus y1 equals mx minus x1. And then we can intersect to get b. So, next one, for coordinates of b. We know that AD equals y equals 1/4 x plus 11/4. We want to note that because we're about to use that. Okay, so for coordinates of B, we want the equation BC. We have gradient MBC equals 1/4. M1 equals M2 for parallel lines. And we have through the point, okay, which one we want to use? We don't have B, so we can only use C, 12, 14. So then we can go straight into y minus 14 equals 1/4 x minus 12. My personal favorite is to get rid of the fraction as soon as possible. So 4y minus 56 equals x minus 12. They haven't told us any specific format in the question, so we can do what we like. So 4y equals x plus 44. Now we've got the equation BC. Now remember, we've got BC and we've got AB. Same point is occurring in both lines, therefore simultaneous equations will get the location of that point. So we've got BC, 4y equals x plus 44, and we've got AB, y equals 3x. So again, we can just substitute. So therefore, 4 by 3x equals x plus 44. So 12x equals x plus 44. So 11x gives us 44, which means that x gives us 4. So y equals 3 times 4 is 12. So our coordinates of B are x is 4, y is 12. And again, back up here. 4, 12, and we just double check. Yeah, it does make sense. Our x is bigger than that one, smaller than that one, and the same with the y's. So we now have A, C, and B. And we remember that we had that wonderful vector step again. The step going from B to E is exactly the same as the step from E to D. So if we can figure out that vector from B to E, then we can just apply it to E to get down to D. 4 to 6.5 is plus 2.5. 12 going down to 8.5, that would be 3.5. So we've got plus 2.5 minus 3.5. So for coords of D, we are using the fact that BE is the same as ED. We are happy with the fact that BE equals up 2.5, down 3.5. So 2.5 minus 3.5. So therefore, D equals the 6.5 plus 2.5. And then the 6.5, 8.5. Hey? Yes, 8.5 minus 3.5. So then D equals 6.5 is 7, 8, 9. 8.5 is 8. 8 minus 3 is 5. So D is 9, 5. And we go back, even though we finished, 9, 5, in between and in between, so it all makes sense. 1, 3, 4, 12, 12, 14, and 9, 5. And if you look back at the working, it's clear to see coordinates of A, here's our working, and our A is. For coordinates of C, here's our working, and our C is. For the coordinates of B, there's all our working with exact details on what it is we're working with and who we're calculating. And there's our B. And then for our coordinates of D, another vector and a final answer. So in your final exam, they probably will do a much better job at giving you the appropriate amount of space. I was being a little bit unrealistic when I added lines into this question. These older questions come from papers which didn't have lines provided. So I'm having to put them in as guesswork. So if you do in your exam go over, you will often have an additional page that you can use at the end. So you would just say, please see page, always give the number. And then when you go to that additional page, always give very clear details of what question it is you're providing the answer for there. Triangle ABC, next question. Vertices at A minus 2 minus 1, B 4, 6, and C 6 minus 3. Show the triangle ABC is isosceles and find the exact area of this triangle. Isosceles, a little bit of revision for you. Isosceles is two sides are equal. Now, in order to show it's isosceles, we're actually going to need to show the length of all three sides, because if all three sides are the same, it's equilateral. So we're going to have to prove that two sides are the same and they're different to the third side. So for lengths of sides, we can do AB equals square root of minus 2 minus 4 all squared plus minus 1 minus 6 all squared. This gives us, let's call for a calculator. So minus 2 minus 4 is 6 squared, so that's 36. Minus 1 minus 6 is minus 7 all squared is 49. So this is now square root 85. We're going to leave it in third form, keep it accurate. BC, moving around our triangle, square root of 4 minus 6 all squared plus 6 minus minus 3 is 6 plus 3 all squared with a square root. So 4 minus 6 is 2, well, minus 2 all squared is 4, and that's a 9 squared, which is 81, which, funnily enough, is a square root of 85. So A, B, and BC are the same length, but we still need to check AC to confirm that it is different. So AC equals minus 2 minus 6 all squared plus minus 1 plus 3 all squared. Put it under a square root. So minus 2 minus 6 is 8 squared, which is 64. Minus 1 plus 3 would be a 2, so it would be plus a 4, which is the square root of 68, which is different. So we don't just leave it at that, okay? We ask to show that we need a statement that is giving the answer. So we need AB equals BC doesn't equal AC. Therefore, ABC is isosceles. We also can now label our triangle because we know that A, B, and BC are our even sides. So AC is the odd one out. So now we need to do the area of this triangle. The exact area, see, I told you it's worthwhile leaving it in surds because the exact area means we need to be working in those surds. In order to do this though, we've got to think of it because we have 3 sides here. We don't have a perpendicular height. So the first thing we're going to need to do is figure out this perpendicular height. But now, how are we going to do that? Well, B down to AC, it's going to hit the middle of AC. So, get away from the pink pen. In order to get that perpendicular height, we're going to call it H, same like we always do for triangles. We know then that the midpoint of AC is where we're aiming for. Midpoint AC is, let's get those coordinates, AC, minus 2 plus 6 over 2, and minus 1 minus 3 over 2. So the midpoint of AC is 2 and minus 2. So what is our height, H? H is going to equal the distance between B and AC. So B is 4, 6. So we have 4, 6, and then we have minus 2 plus 2. All squared under a full square root sign. So 4 minus 2 gives us 2. 2 squared is 4. 6 plus 2 gives us our 8 by 8, which is a 64 again, which is a square root of 68. So now we've got our H. So we can then go to, for area of triangle, we know that area equals 1/2. Our base is AC, and AC is the square root of 68. And then our height is also 68. Well, the root of 68 times the root of 68 is 68. 68 divided by 2 is 34. So just square units, we're working with a graph, we're not working with measurements in this case. So area of our triangle is 34. Our last question, no, I'm losing it today, sorry. Our last question for today is triangle ABC again, has vertices at A, B, and C. The point D is the point on AB such that CD is perpendicular to AB. Calculate the x-coordinate of D. First thing we want to do is to actually sketch this. If we sketch it, let's say there is AB, there is C. So D is on AB such that CD is perpendicular to AB. So there is D. Calculate the x-coordinate of D. So how are we going to get it? We can't say that D is a midpoint of AB because they didn't say so. It is somewhere on AB. So the only way that we can get D, a point in the middle of nowhere with no other information, is an intersection. So we need the intersection of AB with CD. In order to do that, we're going to need the lines AB and CD, two different lines. We're going to have to be very careful track of what we're doing. So let's do AB first because we've got both points for that. And we need that gradient of AB in order to do CD. So for gradient AB, MAB equals y change over x change. So 6 plus 1 over 4 plus 2, which gives us 7 over 6. A lovely yucky gradient for us to work with. Okay, for equation AB. We have our gradient. And which point do we want to use? Let's use -2, -1, as it is a nice, simple, small numbers. So we would then have y plus 1 equals m, x plus 2, because it would be x minus -2x plus 2. Clearing that fraction, 6y plus 6 equals 7x plus 14, which gives us 6y equals 7x plus 8. Now we've got the equation AB. Now we need to do a similar thing to get CD, bearing in mind that gradient relationship. For equation CD, we have MCD equals minus, change the sign, flip the fraction, -6 over 7. M1, M2 equals -1 for perpendicular lines. And which points are we going to use? Well, for CD, we're going to have to use C. So it is 6 and -3. So we would then have y plus 3 equals -6 over 7, x minus 6. Getting rid of the fraction, 7y plus 21 equals -6x plus 36. So 7y equals -6x plus 15. So we've got an equation of AB. We've got an equation of CD. Now we need to intersect those two to find D. We remind ourselves it is just the x coordinate we're looking for. They didn't ask us for the full coordinates for D. So what are our lines? 6y equals 7x plus 8, and 7y equals -6x plus 15. So we want to work for x's, so let's get rid of y. So y equals 7 over 6x plus 8 over 6. Then we can go and substitute in. So 7 over 6x plus 8 over 6 equals -6x plus 15. So 7 sevens are 49 over 6x plus 7 eights are 56 over 6 equals -6x plus 15. Getting rid of those 6's at the bottom there, we would have 49x plus 56 equals -36x plus 90. Rearranging, sorting them all out, we would have then 85x equals 34. And then the last slip of space, then x equals 2 over 5. So just so that's a little bit more clear, x equals 2 over 5 is our final answer. Just the x coordinate of D. So I did a very shocking job of leaving myself enough space on these questions for today. But hopefully that has given you a good overview of some of the working with coordinates kind of questions. we can get, or A is maths for P1.